Welcome to our talk about querying at the speed of light and the end-to-end journey of Druid at Atlassian. My name is Julian, and some of you may remember me from last year's Druid Summit if you actually listened. Maybe not because it was online, but now we're here in person, which I'm really excited about doing this in person in front of you guys. Now, a little bit about myself. I'm a software engineer in the Confluence Insights pillar at Atlassian, which I've been at for the last 2.5 years. Our ownership revolves around Atlassian Intelligence, the generative AI features inside of Confluence, traditional ML applications in Confluence, and the data platform, which comprises of any feature that needs analytical data from Confluence overall. And that's where we actually use Druid. I am a dog dad of 3 herding dogs. After this talk, you can ask me about some of these pictures that I have on my phone. I would show them to you for hours, mainly because my wife made me. Finally, I'm a fanatic about anything fast. I swear I'd probably be Ferrari's leading driver in Formula 1 if I wasn't working on Apache Druid. Well, that and the fast food probably is stopping me. Now, this love for speed is probably what makes me most passionate about the whole focus of this conference, Apache Druid. But before I get too ahead of myself, I'd like you to meet my co-speaker today, Gautam Jethwani.
Hey everyone, my name is Gautam Jethwani. You might have heard about me most recently on the Tales at Scale podcast, like Rena mentioned, or from the 2022 Druid Summit. So hopefully it's good to match a face to the voice. I joined Atlassian right out of grad school, and I've been with Confluence Insights for over 3 years. Confluence Insights, Confluence AI, we have a bunch of different names. I built out the first iteration of Atlassian's generative AI features, as well as working on ML applications and, of course, Druid. Outside of Druid, I like to stay active mentally and physically. You can come talk to me about outdoor rock climbing in the Bay Area, chess, soccer, or swimming. But I haven't been doing any of that because I've just come off of an ACL reconstruction, so you can come talk to me about knee injuries. So now, on to what you're really here for, Druid at Atlassian. Today, we're going to take a holistic look at how we solve our customers' problems using Druid. So let's see what that looks like in terms of numbers. As of today, we are storing 1.8 terabytes of data in Druid. This is compacted into 11,214 segments hosted across 11 regions. This is enough to store Top Gun in 4K 128 times. Now, 1.8 terabytes doesn't sound like a lot, but we're not storing Val Kilmer and Tom Cruise. We're storing billions of analytics events fired by our users. And this is pretty impressive considering an average row size of 50 bytes. So what exactly are we storing? What is this information? We have several events in Druid, including core user actions, such as page creates and updates, reactions to pages and comments, page views, and comments on pages, both inline and global. Ingesting this data enables us to use Druid's nifty out-of-the-box queries to power the features that our users know and love, like the popular feed. The popular feed sits squarely on the homepage of Confluence and is how every power user starts their day. This feed shows you the trendiest pages across your instance. We take the core user actions that we mentioned in the previous slide and fire a top-end query to get the most popular pages within the last 2 weeks. On the flip side of that, we have the following feed. This is a more personalized feed. This feed really highlights the social aspect of Confluence, as you can follow people in spaces and receive the latest updates in real time from your followees. We'll be doing a deep dive into the feeds later, so don't worry. Our first features that we built with Druid were actually user-facing analytics features. These features empower our users to take control of their own data and see the performance of their content over time. It's most useful when someone lies to you about reading their page, because Druid will call you straight out. In fact, we saw this meme floating in the wild in one of the Atlassian Slack channels, and we got legal approval to share it with you. It's always an accomplishment when your team's features inspire memes. And it's not just page analytics that we have. We have analytics at every single level. You can see how your space is performing and even see how this rolls up across your instance. Druid has made Confluence one of the most data-driven collaboration tools on the market. Customers consistently say that analytics is their favorite premium feature. It's been so successful that other teams have asked to onboard to Druid and build their own data-driven features, which led us to build a generic use set of APIs over our clusters and platformize it to power other features. So this is what that looks like. We've designed our API such that any data-driven question can be answered. How many page views do I have in my space? When was the last update on our page? To this day, we are still onboarding new events to Druid and adding APIs on top of its popularity as its popularity within Atlassian grows. Julian and I have been busy. So now Julian will talk about how data moves through Atlassian to Druid.
Let's dig into the journey of an event on its way to landing in your Confluence feeds. First, a user action happens. A perfect example might be a page that is created by a user, such as your teammate, about next month's lunch options at the office. The user action becomes a GASB3 event. GAS actually stands for Global Analytics Service. It is a centralized analytics platform developed by Atlassian to collect user behavior and usage data in real time. It is widely adopted across Atlassian products and supports various use cases by providing a frictionless way to send and analyze data. We have 4 different types of GASB3 events. One of them is a screen event. It is triggered by some user navigation, such as a screen, a tab, a drawer, or a modal. An example of this is navigating to a Confluence page. The second event type we have is UI events. These are fired when users interact with UI elements in the product, examples such as a button, a text field, or a link. Our third event type is track, which is pretty much when a user completes a predefined product action. An example might be creating a Jira issue or viewing a Confluence page. It's essentially the part of a product's workflow. Operational events. These are internal events of our UI components, so think of this as a component initializing and then finalizing, so we can understand the performance of UI components and maybe how we can improve them in the end. Now, the importance of these 4 types of events is that it provides insights into user interactions. It is vital for influencing the company direction and powering the features you see today in Confluence. Now, the GASB3 event will go through Stream Hub, which is Atlassian's event bus, designed to enable decoupled communication between multiple services through event passing. It allows services to communicate asynchronously by publishing and subscribing to events, ensuring that producers and consumers are decoupled and can operate independently. Our events will go through the demuxing service for event region-aware routing and our Apache Flink instances for data quality observability. They are both subscribed to receive that page-created event, for example, at the same time. The Apache Flink instances will cross-check event schema and ensure it matches what we expect to be inserted into Druid in the end. And pretty much it allows us to ensure that no one made changes to the events that we are unaware of, that in that case could cause a data quality issue. And if there is a data quality issue that is noticed via our Apache Flink instances, we will then page the on-call and the team that made the changes to the code to figure out what we need to do to make sure we're in a good state. At the same time, the demuxing service will call a separate service to figure out what region the customer resides in, so that we only send data to the Kinesis streams where the tenant is actually in. Now, here's our Kinesis to Druid regionality breakdown. So we have our system uses Kinesis streams to receive the events, as we've talked about, such as when a page is created, and only in the region of the customer. These streams have a 30-day retention policy allowing us to replay events if necessary. And we have a stream organization of streams per Druid data source. So as you can see here, all activity for the Kinesis stream and all activity for the Druid data source are one-to-one. Now, each event is stored at different levels of granularity, and we maintain separate Druid data sources for different granularity of data. For the Druid cluster configuration in the end, we have 11 region-specific Druid clusters like Gautam's talked about, and each cluster is configured to receive and process data only for its designated region. These streams combined process 375 million events daily. Now, the page created event is then ingested from Kinesis into Druid, And at this time, the data becomes ready for querying. Finally, as a Confluence user, you might see that the new page created by your teammate in your following feed, popular feed, and even in the Confluence Analytics app. Pretty much anywhere we believe will increase the power of collaboration in Confluence. Now, Gautam will talk about one of our most beloved features for collaboration, which is actually powered by Druid.
Thank you, Julian. So if you recall, this is what the following feed looks like. It's a chronologically ordered list of updates across all of the people and spaces that you follow. It's designed to keep you up to date on what's most relevant to you within your instance. In this case, you can see that I follow Julian's dogs. Here's a high-level overview of what that looks like under the hood. You can see from my super detailed, intricate architecture diagram that there's not much to it. We retrieve the user's followees from our DynamoDB data store and then send that to Druid. Here's where it gets hairy. Since we have to retrieve the timestamp of the last update or comment, as well as all of the updates themselves, we have to run 2 separate queries and use a disgustingly inefficient inner join to retrieve the data that the users see. That's disgusting. This year, in the spirit of the Atlassian value of build with heart and balance, we really focused on improving the following feed experience, which you may have hopefully noticed if you use it. Instead of ordering the results chronologically, we wanted to order the results around what was most relevant to the user based on their interactions within Confluence. So we added a couple of more services to our following feed journey. And voila, this is what we ended up with. We trained and packaged a user relevance model with 97 features to score and rank the content that we show users in the following feed. Tekton had just been integrated into Atlassian. And like magpies attracted to shiny things, we wanted to play with this new toy. Tekton is a feature store where features are calculated on the fly for each user and stored. So we retrieve the features from Tekton, send them to our relevance model hosted on SageMaker for inference, and send the results back to the user. All of this fanciness obviously added a bunch of latency to our request journey, so we had to do some serious optimization. And where are we going to do it? In our Druid query. This is where Julian and I put our heads together and really tried to optimize the query to reduce latency. In the spirit of the another Atlassian value, don't F the customer, this is what we did. Here's a simplified pseudocode version of what that query looked like. The full query wouldn't fit on the slide. I tried. So as you can see, we are doing a suboptimal SQL group by, 2 group by queries linked by that horrendous inner join. We thought, why on earth can we not make this a super speedy top N? That's when we remember that Druid will automatically convert a group by to a top N if it can. There's no hope for converting that whole query to a top N, but we can definitely try to do it for at least one of the queries. Using implied clarity to debug and benchmark our experiments, we realized that the pesky having clause in that inner query was the only clause preventing the green query from taking advantage of Druid's sweet, sweet top N speed. So we moved the having filter to the outer orange query, and now we have a beautiful top N query as confirmed by implied clarity. And the gains were monumental. We had a 40% reduction in query latency, which meant we essentially made up for the performance hit of adding Tekton and SageMaker to our request journey, and then some. All in a day's work for me, Julian, and Clarity. It worked so well that we actually did the same for our popular feed query. This is just one example of how we use our deep Druid expertise at Atlassian to ensure our customers are getting the best possible experience. Now you'll hear from Julian about how we use the same expertise to right-size our clusters.
Using Druid at our scale taught us that scaling Druid is surely not a guessing game, but rather requires strategy and planning. For us to be prepared for any change, such as load increase either from organic growth or new features onboarding onto the platform, to maybe even moving to cheaper AWS instances, we needed a way to verify the safety of our clusters with the same scale we expect to see in our real production clusters. We needed load testing for Druid. For that, we needed a solution that was highly concurrent and could send any amount of load that we wanted. To solve this, we chose to utilize Atlassian's internal platform based on Locust. Next, we needed a solution that was replayable so that we could reuse the same queries across tests to hopefully create the most comparable results between runs. For this, we decided to record queries in AWS Kinesis, which allows for retention of up to 365 days. Finally, we needed it to be accurate. So we needed the same data, patterns, and schemas as our real production clusters. To solve this, we created a mirror cluster, which has the same operations as the real clusters for the most accurate results. Here's how it works. When a service calls our CC Analytics service internally that ends up querying Druid, we will query the real Druid database and return the results as usual to the user. But in parallel, we will also check a feature flag to see if query recording is enabled. If enabled, we will write that same query to our Kinesis query stream, which will store those queries for running load tests for up to 30 days. Now to scaffolding the load test itself. From the locust run, we get queries from Kinesis, which returns us up to 10,000 at a time. Those queries will then get written to a query queue, which is just SQS under the hood. This queue will be used for storing the queries that the parallel locust workers will send to the database. Now, I'm pretty sure you're wondering, we actually had to use a queue for the workers instead of Kinesis directly, mainly because of the querying limit on Kinesis streams, which doesn't work well with highly distributed and concurrent load that we generate with locust workers. Now to finally sending the queries to Druid. Each worker will request queries from the queue, then send them to the Druid cluster, the mirror cluster that we've created, at the rate we've defined for the load test. And then obviously Druid will return us the results. And to wrap up that loop, the worker records the latency and reliability of the Druid query, and then deletes the query from the queue so that it can move on to the next query in that queue. In the end, this is able to generate pretty insane load, even to the point where by accident, we ran a load test of 15,000 queries per request per second to Druid without realizing the configuration had a little too many zeros. With this solution, we have been able to cut our cost for Druid by 60% while ensuring 4 nines of reliability and reducing our latency in the 99th percentile to less than 500 milliseconds. With that, Gautam and I thank you for listening to our end-to-end journey of Druid at Atlassian.